What's going on, guys, and welcome back to the channel. Today I'm going to be teaching you the quickest and cheapest, easiest method to mass produce CBD and convert it to Delta 9 that we have ever shown on this channel. Guys, we got a lot to cover today, so without any further ado, let us go ahead and dive right on in to the content. Yes, you already know. Hit that like, subscribe, bell button notification for your boy. Okay, there's going to be a lot to cover here, and it might seem a little complex at first, but trust me, stick with me to the end where I'm going to be giving you the SOP. By the time this little lecture is finished, you are going to be thinking, man, I'm going to literally be giving you all the secrets to the cannabis universe right here in this video. So stick around. It's definitely going to be worth it. I promise. Continuous flow synthesis of CBD, Delta 9, and CBDP. And this could also go for CBDM, CBDB, and all the THC derivatives thereof just by substituting a simple molecule. I'm not even playing. I am Grim from WKU. So let's talk about the anatomy of flow chemistry. A typical flow setup was going to consist of 6 zones: reagent delivery, mixing, reactor, quenching, pressure regulation, and collection. Purification and further analysis are often also included when the end product is collected. In this case, that's going to be the isolation of CBD. So this is going to differ a little bit. So what you're going to see is reactant B and reactant A are going to consistently be delivered. They're going to be mixed together, transferred through the reactor, and then immediately quenched with a very, very low residence time. Then you have your pressure regulation, and finally your product, the end product, which in our case is either going to be CBD, CBDB, whatever that end product is that we started with reactant A and B. Now, the difference between your normal batch reaction versus your flow reaction. Most of my people that have been watching this channel for a while know all about the glass reactor, the boiling flask, all of those different scenarios that you can find right here. A flow reaction is similar to the batch reaction, besides the fact that you are going to be consistently flowing your materials through, and you have to pick your materials correctly to make sure that the reaction is happening inside of the flow and it's just cranking out final product. Guys, this is the way that anybody that can deploy this technology is going to take over the industrial market. First, let me get this out of the way so you can see everything that I'm saying here, okay? So the flow process involves reactants continuously traveling through a reactor vessel to form the desired product. Figure 1. In comparison, multi-step reactions require through step-by-step transformations of the initial reactants to achieve the final product. In flow processes, pumps are used to flow the reaction liquid into the reactor, and this can be achieved by using semi-continuous or continuous pumps. Semi-continuous pumps can be used but may need a syringe or another cannula method to refill those. However, continuous pumps do allow for an indefinite flow of solution, and we all like that word, indefinite. That means continual process flow throughout the entire work day. So some examples of some flow reactors. A lot of us have seen this. This is looking like a recondensing coil that you find in your LPG systems, your packed bed reactor, a continuous stirred tank, which is going to be basically your glass reactor that's been retrofitted to consistently flow through, or a continuous flow reactor chip. Once again, you're going to start noticing reagent A, reagent B comes in here, gets mixed together. This is the reaction time. And then as you collect it out the back end, it is, and guys, you're not even going to believe the residence time. So from classical to modern approaches. By now, like I said, most of the people watching this channel regularly will understand boiling flask synthesis of the major boutique synthetics, THCB, THCP, THCM, using the classical reflux of chemicals method, right? So basically you would find you a Lewis acid, and then you would take your resorcinol, you would reflux those together, right? So the problem with this is that the classical method is the residence time inside of batch reactors, contributing to poor scalability. So here you might have a 7, 8, 9, even in some cases 12 to 14 hour reaction time. This is one of the reasons that these cannabinoids, along with the cost of the starting resorcinol, can go for thousands and thousands of bucks per kilo. It's almost impossible to mass produce THCP, THCM, these other boutique cannabinoids until now. Out with the old. So we'll talk about the old a little bit, just for anybody that's catching up. Friedel-Crafts reaction on olivitol using oxalic acid as a catalyst and terpineol 2 as the chiral electrophile precursor. Sorry, that's a lot of that. Scheme 2. Right, so basically you would have your olivitol, your oxalic acid as your catalyst, and your terpene, and with benzene, mixed with benzene as the solvent, what you would basically do is get CBD outside on the back end of that. In this electrophilic aromatic substitution, upon acid catalyzed water elimination, the allylic carbocation is attached to the less hindered face, yielding the transconfiguration observed in the desired product. However, while this one-step synthesis is appealing, used to be appealing, is still appealing, especially in the, how many people are out there making THCP and doing chromatography to get rid of all of those stereoisomers? Probably a bunch of people. It is appealing. However, we're only yielding about 29% CBD yield due to regioselectivity problems. In addition, C2 competed with the desired C4, resulting in the predominance of the regioisomer 3 and dialkylated product number 4. Moreover, the use of stronger acids, PTSA or trifluoroacetic acid, was deleterious for the reaction, inducing cyclization to the more thermodynamically stable delta-9 THC, and in some cases, this is your desired product. So this is the old method. I mean, this is the method that people have been using to make synthetic CBD and even THCP and all of these different basically that olivitol would be replaced with what? Let's say 5-heptylresorcinol, right? This is the method that you would use to produce some small amounts of THCP. Then you would need to chromatograph that and get that out. Now the problem with it, especially if you were doing any type of CBD, was what you were trying to finish and complete in your final yield, you're more often than not left over with a bunch of the byproducts that you obviously don't want to go into your vape pen. Let's be real, that's what many people are making here. And the problem with that is that also this cyclization is so poor in yield, and when trying to synthesize CBD in some cases, because it's much cheaper than the entire manufacturing process of CBD, synthetic CBD, this has a very, very poor yield. So in with the new plus the SOP, guys, you already know how we do things over here. I'm telling you, straight up. And for all of my members in my Discord, a lot of them have known about this for quite some time. So if you get the chance, check that out. That's popping up in the pinned comment section right there. So in with the new SOP. The first reservoir is filled up with a dichloromethane solution of olivitol and acetyl isopipette. I'm not going to say that right. So number one, this is your first reservoir. While the second one is a dichloromethane solution of BF3 and ET20H with this boron trifluoride ethereate dihexyl ethereate. Boron trifluoride dihexyl ethereate. Whatever. I'm not great at that pronunciation, especially on like 7 cups of coffee. So this is basically your SOP here. So you've got number 1, which is your olivitol, right? That's where we're going to be installing our precursor for our CBD. And number 7, which is your ISO, okay? Basically, all that's happening here. And here is everything that you need to know right here. Look at this. Look at this. 0.1 mole of number 1. 0.05 moles of number 7, your ISO, in reservoir number 1. In reservoir number 2, you've got your BF3, E220 in DCM. So DCM here. Some of these people that have DCM banned, well, I understand that, guys. You're also going to be able to substitute that with a chlorinated solvent. Now you can use chloroform, basically. You could also use benzene, and this isn't a great substitute, but anyway, if you can use DCM, this is going to be perfect for you, okay? So, reservoir number 1, this concentration. Reservoir number 2, this concentration. Continuous flow pump. Imagine this continuous flow pump pulling out of both and just going down our coil reactor. That's it. That's it. Now we are immediately going to discharge out of our coil reactor into NaHCO3. That's going to be our quenching reagent that is going to quench, our quenching solution that's going to quench the BF3 that's in there, as well as any residual acids. So that's going to allow us to wash that out in our final LLE mixture. Literally, it is just this simple. 1 and 7 in DCM being pumped through with BF3 ethereate and diaxyl ethereate and DCM pumped through a reservoir, a residence time of 7 minutes. So what does that mean? Well, that means that from point A, we're going to call this point A, to point B, we want this residence time to take 7 minutes. So you're just going to adjust the flow until you have 7 minutes in and out. And out of that, you're going to be getting CBD that you're going to quench. Okay, now with this setup, CBD can be isolated in a 55% yield, which is, guys, astronomical compared to the previous classical, archaic, whatever adjective you want to use right there, methods that are known in the art. With this setup, CBD can be isolated in 55% yield. Interesting enough, delta-9 THC is only observed in traces along with minor amounts of the regioisomer and dialkylated product. But there's a catch. Extending, that's if you want to make CBD, extending the residence time of 7 minutes will lead to more formulation of delta-9 if that interests you, and I bet it does for a lot of people, as well as using a more concentrated solution of BF3ET2O. That, if you increase the concentrations of both of those and then increase your residence time, and don't worry, I got the SOP coming up for that. If you want that, I got the solution that you need for that, will actually increase the amount of delta-9 that you can make. Now, I really like this because 55% yield after I wash that with LLE, that's enough to isolate. Then I can isolate my CBD with an even less significant loss and be left with a product that was not only quick to produce. Guys, think about all the time that you take to take the biomass, extract it, solvent recovery, filtration, winterization, filtration, decarboxylation, distillation, isolation, washing, drying, all of your isolate. Think about that. It takes a long time. It takes a long time, and that is kind of what is driving the price of those things up. If you could just start with your starting material and you're going to recover all of your DCM, there's very minimal cost that goes into the DCM, although it is a pain in the butt to deal with, and you need to be set up to be able to do that. But by just doing a continual flow through synthesis, you've just chopped the price of CBD in basically half. But wait, there's more. Let's put it all together. The reaction can be washed and then distilled from the quenching container and then just isolated. That's what we were just talking about. Now, by substituting, by substituting a Livital with 5-heptyl resorcinol, for instance, or any other resorcinol that you know about that is well known in your laboratory to make THCB, or the methyl precursor, whatever that enzyme, whatever that is that you are using to make those, let's call them boutique cannabinoids, THCB, M, whatever, you can substitute that Livital with that resorcinol, and in turn, you can make CBDP or THCP in a 7-minute residence time flow through reaction. Now, number 3, here's the important part. Increasing the concentration, doubling the concentration is a better word. By doubling the concentration or the moles of BF3ET20 in the same DCM that you're using and increasing the residence time to 18 minutes, this is going to allow you to reverse make that THC at a 55%. Now, that's going to be collected a little bit more difficult, maybe chromatographed, a little bit more difficulty than just the CBD, as the CBDP can just be isolated, or the CBD can just be isolated and then subsequently converted. Now, since the scalability is perfect and isolating CBD is simplistic, you can produce mass quantities of CBD and subsequently delta-9 for pennies on the dollar. If you can find a supplier that will give you the starting resorcinol at a cost basis that is, agreeable to you during your negotiations, then you can mass produce large quantities of, let's say, so if I wanted to bypass the chromatography all the way, like completely, I wanted to bypass it, then what I would do is I would start with the 5-heptyl to make CBDP, and then I would isolate the CBDP, and then subsequently use whatever standard SOP that I've got, my operating procedure for converting CBDP to THCP, whether that be trisulbutyl aluminum, aluminum chloride, hydrochloric acid. I know some people that are even using muriatic acid, whatever that is that you're using, vinegar, you know, or glacial acetic acid, whatever it is that you're using there, that's, you know, your SOP and your laboratory procedures, but can then be turned around to make that conversion. So you've mass produced large quantities of CBDP. Not only is that a moneymaker in and of itself, but the ability to literally take 75% of the labor force, workforce, solvent, all of the electricity, everything that it takes to make CBD, you can literally start mass producing that. You can even start mass producing your conversion of Delta 9 using very, very little. I mean, how many of us, raise your hand, are adding your trisulbutyl aluminum or adding your aluminum chloride very slowly under a super chilled reactor, and then making sure that you quench it, and then making sure that none of that transfers to your distillation unit, because in the end you don't want any formulation of Delta 8, so on and so on and so forth. Long continuous flow, liquid extraction, you're not going to get out of that. You're still going to have to do that here. But anyway, this is the secret sauce for literally flow through producing basically any high caliber cannabinoid on the market right now. Can be done by simply using flow process, flow chemistry, flow batch reactor size, and just taking your subsequent starting resorcinol. For CBD, that would be a Livitol. I already gave you another one, which is 5-heptyl resorcinol. And check either one of these videos that are popping up, and you'll be able to see all of the different resorcinols that I've given you for B, M, H, you name it. So you can install that there and do your continual flow processing the exact same way in 7 minutes. In 7 minutes. Guys, it's a Christmas miracle, and I'm super happy that the holidays are coming up, and I hope you all had fantastic Thanksgiving with your families. I have a lot to be thankful for. One of those things is you guys. I'm very thankful for every single one of the members on the channel, and the members of the Discord, and all of the students and people that we teach with. I'm very, very thankful for you, and I know, I can just tell you're going to do amazing things, and I'm just so blessed to be a part of it. With that being said, it has been a blessing, a privilege, nay, an honor to be able to teach and consult with you guys. I will see you in the next video, and we finally got some time to start mass producing these, so I got plenty of more information coming for you. Stay tuned. Peace out.